Hello, lecture masaju Newton's three laws to relate question is solve na Newton's first law, second law, third law bol chayoten. So today to nya free body diagram ho ahin the normal chule tension cc you bol hinden next get phal khon friction na friction force bol dio. Okay, so let's see. Normal I lud masang win force kiti phal na types of force alhang pia physics at force ki hop khendan he piha. So force can be divided into contact and non-contact. Contact ki chu ke su khana non-contact chu ke su khala body ni ke su khala force pa su non-contact ki hiza chila hi gravity jong non-contact force chula na gravity abale electrostatic force ti chu charge between charge like charge repels unlike charge attract yo kona abale magnetic force to in presence of magnetic field contact force ke ti phala chun body ni ke sukhate de tin so two bodies are in contact, right? So they touch each other. Contact force are he further classification na so you will have friction, okay, you'll have tension, and then you'll have normal. Friction force, tension force to normal force athoma hina chilai loss of motion chapter ahi it discussed the winten hiti non-contact force la hi gravitation pa hi. So this is I think it is chapter number 6 7 or class 11 part 1 last chapter khona chu gravitation is electrostatic to magnetism hi class 12 okay, so this is for class 12. Gravitation and all contact forces are in class 11. Okay, class 11 mechanics. Hotile to hi friction force, tension force to normal force involved. Na hi contact force nu ya miza is a loss of motion chapter hi bonam. So before going into normal, some basic thing. SI unit of force biha Newton. Okay, force ke siding phala chun 10 Newton na example so 5 Newton tia ko unit of force to Newton. So and one very commonly used conversion to 1 Newton equals to 10 power 5 dyne. Just keep in mind. Na. Okay, let's start. Free body diagram. Loss of motion chapter na question khat aki solve dinga la chun example to question khat ong ki pi na figure real life to ki relate question khat example block na elola tension to ki relate elola friction to ki relate ho question ong ki do ala chun alhang pi khala chu question ki dong pa cha free body diagram ki dikha ki draw ma sabeta na chu pi ham tele so free body diagram is basically the representation of all the forces acting on the body. Suppose I have a block. Okay, so this is let's say 5 kg. So this block is lying on the ground. Ilo table so ki koi na ta he. Kutile chi block pa hi zi langai ta ki kai cho. Okay. Force khala ki kai na. So at some angle. Kutile chilai block ka hi force ppm. Okay. So if you want to see how many forces are present in this block, indikazi de ha chilangai force khatom na F. Okay, at some angle chikyu se chu helwa block pa hin mass jong na chula na mass jong na yala chun weight jong ti na cho weight to force cho. So that means if the mass is 5 kg, a weight to mg na mg to downwards to 5 mg 5 into 10, so which is 50 newton. 50 newton anu lang am de na abala chi phala normal force in sim the normal force ki teach contact for contact om na jaw sia chu normal om na chalai jong hibela chun hilai jong hi normal ta khat om de so to I had you to free body diagram ke hi pt na ham ti head me de jana chalai hi. So if I represent all these forces which are acting on the body, okay, so this is the free body diagram. Chepen hi na hi chepen free body diagram ke teach chilai block ahi 5 kg ahi force ppm F na abana contact surface zi ahi normal khat hom ding abale block in mass and ja weight jongom de na hi jo si tai figure round ke represent ala chun jo free body diagram ke ti cha. See one more example I will show you. Hi tai block ke koi chona tai block ni say 2 kg 3 kg solve dan pa hi in ball diu jana normal phale so don't worry khutile jala hi block nium cho 2 kg block to 3 kg block achum chuma free body diagram a kg phale khonna. So when you write the free body diagram, you write it separately for different system. Jala hi 2 kg pa hi chuma kg ding 3 kg pa jang hi chuma kg ding hita hi chum chuma kg ji cha khutile jala hi video chun 2 kg pa hi mass 2 kg nei chura na khutile weight anei ding weight to mg. So that means 20 Newton. Abana contact surface to chilahi chula na chilahi. Contact surface ji ajo normal hungom ding ajung lang lahi. So normal on 2 due to 3. Abana jo 3 kg pa jong hi mass anei ji ajo weight den na weight jonui langa 30 Newton. Abana ground to 3 kg contact chula na. So due to the ground you will have one normal due to the ground. Okay. And then due to the 2 kg tang nachung achon mi kharam nachun you will feel that that person is pushing you down na you'll feel the weight. So that weight is the normal force on 3 due to 2. Okay, so like this khotele 3 kg a block force si chuna he khacho normal due to the ground hisa khacho normal due to the 2 kg hisa khacho weight of the block he chi ho se si hi ta am ke represent ale chipen hi free body diagram ki teacher. Okay, and similarly on 2 kg block, so you have 20 is the weight of 2 kg and due to 3 kg you have normal. Okay, so representation of all these forces, all the forces acting on 2 kg. Okay, so this is the free body diagram of 2 kg block. Okay, so next you have normal force. Out of the 3 force, this lecture will do normal and tension. Friction part chu aket pa le bol yo aje chu topic hoi ali na len thai hen na detail ta sai di normal me me jong lecture khara lung ke bol thai hin but we will try to complete normal and tension in this video. Masapena so normal chu piha. So normal force is consistent with the Newton's third law. Newton's third law chu action reaction pair pa khona action equals to reaction pa kho. Chipa here you apply phala can explain this ani na chu normal force exists wherever okay contact surface exists between two bodies. Body ni chu contact a hungum phala chun na contact surface na jaw sia cho. So wherever you have contact surface there you will have a normal ale athum na chu pe. So normal force is perpendicular to the contact surface. Contact surface to perpendicular as na normal hungum this. Okay, so it is always perpendicular to the contact surface. Ali na final acho it acts in such a way that it tries to compress the body. It's a point to na. It's all he so we'll try to use these things in solving questions. Example, I have a block. One block lying on the ground. Say the mass of this is m. Khutile ama sapena a free body diagram in zidu tajo. So if I want to write the free body diagram of this block, okay, so I have the mass m, block in mass m and to weight of ngai na. Weight of the weight to always downward, weight to gravitational force chalana. So downside you have mg. Okay, gravitational force mg is weight of a body is always downward. Khutile chalai contact surface is anama. Contact surface khal jina je. So if you have one contact surface, you will have one normal. Okay. If you have two contact surface, you will have two normal. Khutile contact surface khat bo si am chalana. So therefore you will have only one normal. And the normal will act in such a way that it tries to compress the body. Point number 1 na. It is perpendicular to the contact surface. Point number 2. Okay. So that means it is idu ha. So first thing, the contact surface to which ha. So this is the contact surface. Okay, I have to draw perpendicular to this contact surface and tries to compress the body. Khutile it will be in this direction. Okay. Value chun arrow direction pa hina compress chula na body hi a block pa hi a compress intin abana chu it is also perpendicular with the contact surface. Okay. So usually we write it all the way like this. So this is normal on the block. Okay, N. Force dang nanayam. So there are no other forces, right? So N and mz is here. If the block is at rest, block so what is the meaning of that? The meaning of that is, so if the block is at rest, its acceleration is 0, so therefore there is no net force. So Newton's second law. Okay, so here if the net force is 0, so here net force F summation of all the forces equals to 0. Kutile normal so chung lang na. Mg so nui lang ko minus mg equals to 0. So that means n is equals to mg. Normal to hin mg pa hai na ki cancel out ta so ki bang. Chizia so net force 0. If the net force is 0, acceleration is 0, the body is at rest. Okay, so let's go further. Newton's law sungana, laws of motion sunga question ki solve phale equation in manu chu piham Newton's second law ko F equals to ma hang pot chalana. So we have said that F equals to ma. So here F is the net force. Okay, so this thing is the net force. Na chi pen last video patya ka explain da cho khudile khada vector ki phala chun x coordinate, y coordinate to z coordinate chalana. So for these three different coordinate, I can write this equation, okay, for a respective coordinate. Summation of fx equals to max, chi x axis langa. Summation of fy equals to may, chi y axis langa na. Abana summation of z equals to maz. Second law pa ko na f equals to ma pa ko x axis, y axis to z axis achum chuma ta gi thai cho. Question ki solve phale khun. So mostly we will use only the first two, x, y. Okay, we don't athoma hi za lo mai theo na x to y. So in most of the cases we use x and y. Force khat chu examples of force khat chu, if the force is neither along x nor y, okay, I have to split that force. So once I split that force, I will have x component and y component. In that case, I have to use these two. Okay, x component and y component. So along the x component, fx equals to max. Along the y component, fy equals to may. Aban le chilaya summation giti hai na, chipen sigma pa hai. So this means the resultant, okay, the sum of all the forces. Sum tine so sigma pa hai. Let's solve some examples. Example, normally bolo jana to hai. Suppose I have two blocks, so 1 kg and then 2 kg. Question 2, calculate normal between 1 kg and 2 kg. Question also bham dela 1 kg to 2 kg ki ka contact chala na. Ko contact mala chun 1 kg to 2 kg ki ka normal jo ipiham. Okay, so what is the normal between 1 and 2 kg? So that is the question. So you draw the question iti amko do phala na. So first thing is you have to draw the free body diagram. 1 kg pa chu tema 2 kg pa chu. Okay, so there is the 2 kg. Mass and chi chala na, mass or mala chun weight te dio. So that is mg 1 into 10, so that is 10 Newton. Mg 2 into 10, so which is 20 Newton. Abale contact surface omna jaw sia chu normal te na. Khutile jalai contact surface is between 2 kg and the ground, I have one contact surface. Surface khat omna. Abale chun between 1 kg and 2 kg, I have one contact surface. Contact surface niyo mala chun normal niyom de na. Okay. So between 2 kg and the ground, I have one normal. So which is, let's say, normal on 2 due to the ground. Okay. Abana chu piha 1 kg to 2 kg ki ka chu contact surface kha chala na. Azawa is chu tang. Normal force, point number 1 penny, is consistent with Newton's third law. Newton's third law piha action is equals to reaction. Khutile chala he beta. So if you imagine yourself as 1 kg, okay, 1 kg dan ki gel chun 2 chunga hona taw chala na. 2 chunga na taw wala chun you will feel the force, a push force from 2 kg, okay. Na che chu betang 2 kg, imagine yourself as 2 kg. Okay, you will feel that 1 kg above you, so you will feel the weight of that 1 kg. You are going to feel a normal from 1 kg. Okay, if you are 2 kg, you will have this normal on 2 kg due to 1. Na, it's normal khata normal on 2 due to 1. 1 achunga achu 1 in asot su na. So you will have a normal on 2 due to 1, and also at the same time you will have normal on 1 due to 2. Okay. Chilaya chitohin chihina chi Newton's third law valid na. So Newton's third law application just mean. So if you see these two forces are exactly equal, okay, and they are opposite. So here you should know that normal on 1 due to 2 magnitude is equals to normal on 2 due to 1 kibangsat. And their directions are different. So normal on 1 due to 2 is equals to minus of normal on 2 due to 1. Na equal and opposite kiti pajo jihicho. So equal in magnitude and opposite in direction. So that is Newton's third law. Okay. Normal is na. So if you have two bodies here, okay, you always have to draw two normals like this in opposite direction, same magnitude. Okay, so between any two body in contact, you are always going to draw two normals in opposite direction equal in magnitude. Okay, you have to satisfy Newton's third law. Okay, hotile chila hi must happen as a free body diagram draw di jana to hai free body diagram ta cho japan here. So once you finish drawing the free body diagram, now you have to apply the equations. Chilanga equation is yaw. Okay. 1 kg evaluation force is vertical chalana si. So either it is upward or it is downward. Okay. If you look at 2 kg, so all the forces are either upward or downwards. Khutile equation thumlai ho japan kabande ha. I have to use the y component. Okay, vertical component. Fy equals to may chepai kaman ngai cho. Okay, so let's use in 1 kg block. Okay, one more thing, sign convention he so throughout the whole course, okay, kai lecture daw sia hai na regular coordinate system pa ho iman diu cha. So here I have xy. So xy, this is plus y, okay. So this is minus y plus x and minus x. If any vector is pointing towards the plus x, it is positive. Okay. If any vector is pointing downwards, it is negative. If any vector is pointing upward, which is that is positive, and if any vector is pointing towards the left side, it is assumed negative. Jeju sign convention. So Hutile 1 kg block evaluation n1 2 pahi n1 normal on 1 due to 2 n1 2 pahi upwards chulana upwards to plus aka isum so plus abana 10 pahi downwards chulana, so that is minus 10. So this should be equals to what? So the whole system is at rest means acceleration is 0. Okay, so what is the value of n on 1 due to 2? So 10 Newton. Okay. So by Newton's third law, tell me what is the value of n on 2 due to 1? So this is equals to n on 1 due to 2, so which is equals to 10 Newton. Hutile n on 2 due to 1 jong value ki he ta cho. Okay. Hutile to on in 2 kg block. Okay. N on 2 due to ground who upwards na plus n on 2 due to 1 pa who downwards chulana minus abana weight 20 yung who downwards, so minus equals to 0. Whole system is at rest. Kutile value population n on 2 due to ground minus n on 2 due to 1 sujan ha 10 na chunga pa ko minus 20 equals to 0. So therefore what is the normal on ground? That is 30 Newton. Question between 1 kg and 2 kg. Between 1 kg and 2 kg okay, so this is what they ask. Na extra ken jong ground to 2 kg ka normal pa jong ka derive to ta jong ka solve ta na. So these are the two normal forces acting on the whole system. Okay. Okay, next. just for practice ground chila hi block khat achunga hi block khat achunga chong block khat ket zala di ha. So let's say this is 2 kg, chi hi 3 kg, chi pa hi 5 kg. Okay, question so piham. So find the normal between all the normals. Khutile step 1 so piham free body diagram draw ngai de na. 2 kg pa khu draw tao. So 2 kg pa khu downwards to weight chula na, weight to 20 hungom ding nui langa achung langa he piha normal pa khu bita normal pa khu between 2 kg and 3 kg there is contact surface of civil hilai contact surface khat chilai contact surface khat hilai contact surface khat na contact surface thom so. Okay, so therefore you will have how many? So 3 normals. Okay, so on 2 kg between 2 and 3 there is a contact surface, so normal on 2 due to 3. Okay, abana to 3 kg. So this is 3 kg. 3 kg so weight na weight malachun, so downwards 30 newton. Kutile due to 2 normal so hilangam dia downwards. So normal on 2 normal on 3 due to, okay, I'll use the same color as before. So normal on 3 due to 2. Na achunga 2 ji acho. Kutil anu ya jong he 5 na rai chole na. So due to 5 you'll have, so normal on 3 due to 5. Okay. So remember, normal is always perpendicular to contact surface. Okay. And it should act in such a way that it is trying to compress the body. Okay, this is trying to compress the body. Change 2 kg compress na. Kutile 3 kg normal umdo se chuki saita abana chu pm, so abana chu 5 kg. Okay, 5 kg. 5 kg chu 50 newton weight. Kutile ground to 5 kg contact arm chula na. So due to the ground you'll have, so normal on 5 due to the ground. Okay, and due to 3 to 5 chu contact arm na. So due to 3 you'll have normal on 5 due to 3. Kutile free body diagram ki chaita na abana chu pham equation ji de. So here let's write in 2 kg. Okay, force jo si evaluation force jo si vertical chura na, vertical hi alachun Fy equals to may. So summation of Fy equals to may. Normal on 2 due to 3 chepa hi upward akole chepa hi positive, 20 hi downward akole 20 hi negative. So that means n on 2 due to 3 plus minus 20 equals to mass to 2 into acceleration to 0. Okay, so from here what do you have? N on 2 due to 3, so this is equals to 20 newton. Equation number 1. Abale to hi normal on 2 due to 3 mutao chula na. So by Newton's third law, so normal on 3 due to 2 is equals to normal on 2 due to 3 is at 20 newton. Kotile to hi normal on 3 due to 2 chi value jong ki muta cho. So now in 3 kg. Na 3 kg ahi force equation ji kita Fy equals to may. Chilahi n on 3 due to 5 chepahi upwards na, chepahi upwards chepa so positive, n on 3 due to 2 is downwards so negative, and 30 is also downwards so negative. N on 3 due to 5 plus minus n on 3 due to 2 plus minus 30 equals to 3 into 0. System to raise an acceleration to 0. N on 3 due to 5 minus n on 3 due to 2 is at 20 na, 20 minus 30 equals to 0. Kutile n on 3 due to 5 is at 50 newton. Okay. Normal force on 3 due to 5 kg is 50 newton. Abale Newton's third law naman falachun. So similarly, normal force on 3 due to 5 due to 3 is equals to normal force on 3 due to 5 equals to is at the 50 newton. Na hotele 5 kg achu. So in 5 kg block, summation of fy equals to may bola chun n on 5 due to ground pa hi upward na chu plus, n on 5 due to 3 to downward minus, and 50 newton to downward, so it is negative. It is idiota. So normal on 5 due to the ground minus normal on 5 due to 3 to 50 minus weight to 50 na equals to 0. Hotile is that normal on 5 due to ground to 100 newton. Okay. Okay, next one more example. Suppose let's say I have a wall to ground na chala hi block jata hai. So here a force is acting. Okay, so force is acting at an angle say 37 degree. It's a force F depending, let's say 100 newton. Na mass of block to say 5 kg. Question to calculate all the normal forces. Question to contact surface is that one. Between wall and the block you have one contact surface. But between the ground and the block you have one contact surface. So there are two contact surface. Okay. Kutile normal so niyom de. Let's draw the free body diagram. So I have 5 kg. 5 kg hi mass of 5 ahile weight is at them. So weight is always downward 50 newton. Abana force pa combination, so that force is neither x nor y. Okay, so we have to split that force component ila ngayon. So here I will take one component is like this, another component is like this. So angle is 37. Okay, let me use different colors here. So I have 50 force pass with I have to split this force. Let's say one component is like this, another component is like this. See here 37. Kutile 100 chala force so. So this side will be 100 cos 37. The side which has the angle is cos. Abana chung lang pa 100 sin 37. Naka split alachun. Abana so normal to BPM. So between the wall and the 5 kg, I will have one normal along this side. Contact surface to itiamza normal to perpendicular hingai, and it also has to act in such a way that it tries to compress the block. Okay. This is the normal on the block. Let's say N1. N1 to become normal due to the wall. Abana so due to the ground, you should have another normal. So let's say this is N2. N2 is due to ground, N1 is due to the wall. Kutila chila heavy force or he x lang force y lang force na. So now you have to apply both x equation and then y equation. Masapena cho along x axis. X axis lang cho piha ko equation so fx equals to max. Na z lang ko jo se plus, y lang ko jo se minus. Kutila chila heavy horizontal high force is 100 cos 37 oma n1 jang chala na. N1 pa he z lang ko 100 cos 37 hin y lang ko. Kutila n1 pa he positive ding, 100 cos 37 pa he negative de. Okay, so I have n1 plus minus 100 cos 37. So this is equals to 5 into 0. Block to rest arm. So that means the acceleration along the x is also 0. So therefore n1 equals to 100 into cos 37 to that term 4 by 5. Okay, so how much is this? 1 is 5, 5 2 are 10, 80 newton. Normal due to wall to 80 newton. Okay. Abana to along the y-axis. Along y-axis, equation to PDM, summation of fy equals to may. Kutile achung lang ko so plus na y-axis lang anui lang ko so minus. Kutile n2 he value so n2 he chung lang ko so na. So n2 is positive plus 50 is downwards, so 50 is negative. So this should be equals to 5 into 0. acceleration upward adang to 0 kutile n2 is adang podam n2 is equals to 50 newton. Okay, so we have got the answer for both. So due to the wall is 80, due to the ground is 50. Okay, so let's start solving exam questions. Masa penaju chehe NEET question na. A horizontal force 10 Newton is applied to a block A. Diagram azon kepi na. The mass of block A and B are 2 kg and 3 kg. The block slides over a frictionless surface. The force exerted by the block on between A and B. A to biki ka normal force na so. Okay, first you draw the free body diagram. Two kg to 3 kg na. Kutile weight jonui langam ding. So 20 Newton and then 30 Newton. So between the ground you'll have let's say this is n on 2 due to ground, and this is let's say n on 3 due to ground. Abanle village on horizontal azong force ki apply chula na. Masa penan so 2 kg village on chilanga hi 10 Newton ki apply cho. Abana so between 2 and 3 you have contact surface. Okay, so that means you will have one normal on 2 due to 3 and another normal on 3 due to 2. Okay, khotile to hai contact surface zosia normal zosia draw taw na. Question chun pido ham find the force exerted by the block on B. Khotile normal on B due to A tinai cho. Na normal on 3 due to 2 tinai cho. Question hin horizontal langbo do chola na normal pa hai. So we don't need to solve the vertical part. Okay, you can simply apply fx horizontal component equation. You will get the answer. Khotile chila hebela jun whole system pa hai to hai race am lauta cho. Okay, so must appearance you have to find out by how much acceleration the whole thing is moving. Khotile kon vela jun 2 and 3 are in contact. Okay, so what I can do is I can think them as one single block. Hitya here. So I have one single block of 5 kg. So this is being pushed by a force of 10 Newton. Khotile acceleration chuzad ham force divided by mass. Chichu 10 divided by 5. Chichu 2 meter per second square. Okay. 2 kg to 3 kg to contact am ja chu chi kho hone jora na no wale. So both of them will move with how many acceleration? So 2 meter per second square and 2 meter per second square. To hi acceleration 0 talo cho. Okay, so that means in the 2 kg let's start with the 3 kg. So in 3 kg, so fx equals to max. Na zilanga ko n on 3 due to 2. Heje pa zilanga ko, so this would be positive. Okay, so that means n on 3 due to 2. So this is equals to mass to 3, acceleration to 2. Force dang mazam law na. So this is how much? 6 Newton. Okay. And by Newton's third law, n on 2 due to 3 should be equals to n on 3 due to 2. So this is how much? 6 Newton. Actually, this is your answer. Okay, so directly you got the answer. 6 Newton. Question chun do na between 2 kg and 3 kg normal is at ham. Okay, so that is 6. Okay, you have one more question. 70 kg garden roller is pushed with force 200 Newton at angle 30 degree with the horizontal. So the normal reaction on the roller is, see, here's a diagram by free body diagram kan manjing it. So here if you see, the force is neither along neither along x nor y na. Here's a some angle arm na. So you can split this force. Okay, so one component is like this, another component is like this. The angle is at 30. Okay, so that means this is f cos 30 and this is f sin 30. Question should be the normal reaction on the roller. between the ground the contact surface hi hulama chila hi chalana. So here you will have one normal. Okay, so contact surface so it is like this. So therefore the normal has to be perpendicular to this and trying to compress the object here. Okay, so be perpendicular and trying to compress. So let's say this is n. Okay, I'll just draw the different free body diagram na. Roller circle arms on. So you have the weight. Okay, 70 kg roller kitilachun. 70 kg means what? 700 Newton. Okay. Abale vertical langa hi f sin 30 zo chalana chi. F choose an 200, sin 30 to 1/2 to 100 Newton. Abale normal to chilanga he n. Okay, kutile force of si value chun vertical chalana. So Fy equals to may. Vertical langa hi acceleration om them. Tu hinga value chun chi wheel pa hina hoilanga chi them. Force it and short value chun chilanga chi chalana. So it will rotate like this. Okay, it will move along the x, not y. So along the y acceleration is 0. F along the y achu, I have n, okay, plus minus 100 plus minus 700. So this should be equals to mass to 70 into acceleration to 0. So from here, what will be the normal? You will have 800 Newton. Okay, so this is the answer, 800. Okay, so we'll move to tension force. Tension is let's just go back and revise. Normal to it always x wherever you have contact surface. Okay. Second thing is it is always perpendicular to the contact surface, and third is it acts in such a way that it tries to compress the body. Question friction down normal question tamta. Next video long solve bedings. So for now, just to give you the idea, now normal basic calculation akimandan paso here na dinga chu tempat ibol masalo hin. Okay, so let's move to tension. Tension chu hulayam ha. So first thing, tension always acts on strings. Okay, wherever you have strings, there you will have tension. Ani na pen chu strings ki mang ho na. Question na haokipiit ta lawala chun alhang pi so in most of the cases it will be massless and it is inextensible. Kisung thailo din cho. Kisu sao thailo na. Okay. And then see, important thing is tension always acts along the string. Direction of tension force so na. It is always along the string, and second thing is it always acts in such a way that it tries to decrease the length of this wire. Suppose I have a block mass m. So let's say this block is hanging, okay, from a wall by a string. String kutila direction of tension so it always acts in such a way that it tries to decrease the length of the wire. Kutila, see, that is possible if I draw a tension like this. T. Na a direction pa relation, so it points towards each other. It tries to decrease the length of the wire. Okay. Tension hita hen okay, you always have to draw tension like this, right? As it's a wire he n niums okay wire n he relation niums na there are two ends of a wire. Okay, so from each end you draw a arrow like this, so to show there is a tension in the wire. Okay, let's just use that concept we have just learned. Example, I have a from a rooftop by a string, I have, let's say, 5 kg block hanging. Kutele wire attention here is an item. So whenever you have a string like this, you draw a tension. Okay, so like this. So this is T, this is T. Okay, free body diagram nan draw phaleo na. So you have to draw this part. Okay, so this part, how will it look like? So 5 kg. Asung ako tension T, ano yung lang weight 50 Newton. Abala adang force mo na na, and all the forces are along the y. So Fy equals to MAY. Okay, so T plus minus 50 equals to 5 into acceleration 0. Whole system is at rest. Kutile tension chujan ham 50 Newton. That tension ki boldan basic. Okay, one more thing here. Example khata bol beta na. Okay, next page. Example. I have a block. So let's say this is 2 kg, and below this I have another block. So let's say this is how many? 3 kg. Question chun, find the tension on all the wires, all the strings. You have one string here and this string. So one thing you have to note here is that this string and this string are not connected. Okay, so they are different strings. So this string and these strings, so they are different strings. Okay, so different strings means what? Different tension force. Okay, string chum chum hala chun tension chum chum ai hingai. String khat akiba ala chun, so same tension. Okay, so one single string, same string means same tension. So different string means different tension. So here I'm going to draw. So this is T1, let's say, okay, and this will be T2. Okay, kasi banga so free body diagram na draw phala chun chelai ka hai na, to chelai ka hai. Okay, so the first one, 2 kg free body diagram chitin ji 2 kg achung langa hu T1 oma anui langa hi T2 na. Abana cho mass jongum ja cho weight jongum cha nui langa weight 20 Newton. Okay, so this also abana 3 kg pa khola. So this is 3 kg achung langa hi T2 oma anui langa chui ma cham lo na weight bo se am 30 Newton. Okay, so you apply the force equation here in 3 kg. Hita equation ki pi phala anui lang be pena hen na pan leo chun. Okay, so always start from the end. So in 3 kg I have T2 plus minus 30 equals to 0. Okay, so force into acceleration 0 chola na. Kutila chalai ko na T2 janang ponam. T2 equals to 30 Newton. Okay, abana so next to in 2 kg. 2 kg ahi achung langa T1 na T1 positive plus anui langa so T2 ma abana chu 20 jongom na anui langa so this is equals to 0. Kutile T1 minus T2 chujan ham 30 minus 20 equals to 0. Kutile T1 chujan ham podam 50 Newton. Okay. So one more question. Example. So what shall we take? Let's take 3 na, just for practice. So 1 kg. Okay, so let's say another one here, 3 kg. Okay, and then one more here, let's say how many? 5 kg. Okay, just for practice. Block thom ta ke khai na. Okay, masa pena chu pin bol ham. So T1, okay, and this is T2. Okay, so this is T3. Na free body diagram ji na ka sai chula na. So you have to draw, this is the first part. Okay, so 1 kg achung langa he T1 anui langa ho T2 abana weight jong 10 Newton. Abana chu he chika hi middle portion na 3 kg 3 kg chalai ding anui langa ho T3 oma achung langa ho T2. Hichalai ham 30 Newton. Okay, so finally 5 kg. So this is 5 kg. 5 kg. Anui langa hi 50 Newton. Achung langa ho T3. Okay, so start from the bottommost point in 5 kg. So T3 plus minus 50 equals to 0. So therefore T3 equals to 50 Newton. na tension between 3 kg and 5 kg is 50 newton abana chu in 3 kg achung langa ho T2 plus anui langa chu minus T3 plus minus 30 equals to 0. So T2 minus T3 chu jarang podam 50 minus 30 equals to 0. Kutile T2 chu jarham 80 newton. Na 1 kg to 3 kg ka tension chu 80 newtons. So finally in 1 kg. So in 1 kg what do you have? So T1 plus minus T2, okay, so plus minus 10 equals to 0. Kutile T1 minus T2 jarham 80 minus 10 equals to 0. So finally what is T1? 90 newton. Okay, so between the roof and the 1 kg it is 90 newton. Between 1 kg and 3 kg it is 80 newton. Between 3 kg and 5 kg it is 50 newton. This is tension ke holna na. So I hope you got the idea. Tension 80 kg ding ham na force equation 80 kg ding ham. Okay, how to draw the free body diagram. So all those things I want you to know. Okay, basic ikil na. Okay, so let's solve some questions. First is a Z-main question. Ita he block thum ki kai na chila he. So block thum ki kai tin I have 5 kg, I have 3 kg, I have 2 kg. Question chen pido ham what is the tension T1 and T2? 5 to 3 ka tension to 3 to 2 ka tension pa hai na. See horizontally smooth surface friction umlo cho chila he. Kutile 80 newton ana kaya la chun upon y ke mat chula na. So they are see they are connected. Okay, so that means all of them will move at the same acceleration. Ki bang chara na speed ki bang chara chi diu ja mo thame, right? So here I will just use the figure here. Chila hi chi T1 chi hi T1 na chila hi T2 chila hi T2 abana chila ngai force cho. So you draw the free body diagram. So this is the first part. 5 kg z langa chu T1 in kai na. Okay, abana chu pe ha. So this is the second part. Chu 3 kg. 3 kg z langa hi T2 in kai vai langa chu T1 na. Abana chu finally you have the 2 kg. 2 kg z langa chu zan kai force in kai chula 80 newton in kai na. Vai langa chu pm vai langa chu T2 Apale say bang ma so abon chang kai vai same acceleration chi du jala na. First you have to find out the acceleration. Okay, so if all of them are moving together with the same acceleration, so I can think of all of them as a single block. Okay, so I can think all of them as a single block. Mass that they have 5, 8, 9, 10 kg. So this 10 kg is being pulled by 80 newton force. Kutile acceleration chu that ham. So force divided by mass 80 divided by 10, so which is 8 meter per second square. Okay. So that means each of them is moving with 8 meter per second square. 5 zong 8 meter per second square. Na 2 kg zong 8 meter per second square. Acceleration anay uti na ito. Okay, so now let's find T1, T2. Always start from the the last part, 5 kg. So in 5 kg, if you have a equation for T1 ko zilang chala na, zilang means positive. So T1, so this is equals to 5 into acceleration to 8. So this is 40 newton. Okay, you have only T1. So next is in 3 kg. So in 3 kg, zilang ako T2 plus vailang ako T1 So this is equals to m into a 3 into 8. Okay, so how much is this? T2 minus T1 to 40. So this is a 3R 24. So therefore what is T2? So this is 64 newton. Answer choose at 40 to 64. Option A. Okay. Question about solve masang win no. Just before that I want to give you one theorem which will shortcut the question also, so it will give you it's like a shortcut dabang. It will make your solving questions much easier and shorter. Okay, jujupyam tele Lami's theorem. It's a class 12 electrostatic azong kibang di so where used in most wherever you have force, right? If you have a particular situation, it can be used in particular situation where you have three forces separated by some angles. For example, I have one force F1 along this side. Okay, I have another force, let's say F2 along this side. I have another force F3 along this side. Let's say the angle here is alpha, angle here is beta, and angle here is gamma. Okay, Lami's theorem. So Lami's theorem is basically F1 divided by opposite angle to alpha sine alpha. So this is equals to F2 divided by sine beta. So this is equals to F3 divided by sine gamma. Chipahe Lami's theorem kiticho. Okay, so you just remember only the formula. Na chalai as force umdan hoy chipa to hin. So you have three forces. Okay, so F1 divided by sine of opposite angle, F2 divided by sine of opposite angle, and then F3 divided by sine of opposite angle. Okay, so that is Lami's theorem. Okay, so here I have one question. Mass 2, so block of mass is a body of mass 1 kg is given, suspended by two strings, tension T1 and T2. Question T1 to T2 also na. So here you see you have different strings. So these two strings are not connected. Okay, aki connect lawasun, aki ba lawasun, string chum hirasun, tension chum hingai na. And here you can see that the two tensions are neither along x-axis or y-axis. So they are inclined at some angle. Component langai chula na. So let's take the component T1 to which is at here. So I will have here T1 cos 60 and T1 sin 60. Okay. Abana chu T2 janghu hilanga T2 cos 30. Abana chung langa chu T2 sin 30. So now you see all the forces are along the x and y. Okay, so now I can start using fx equals to max or fy equals to may. Lami's theorem apply masanga general concept paso na chipensi pol masadeucha. So here if I try to draw the free body diagram, I have the block nui langa hizana mass 1 kg chula na, mass 1 kg hilachun, so weight to 10 newton. Kutele z langa hi, so T2 cos 30 to be root 3 by 2, so root 3 into T2 by 2. Okay, vai langa chu T1 cos 60 to 1 by 2, so T1 by 2. Abana chung langa chu T1 sin 60 to root 3 by 2, so root 3 into T1 by 2. Abana chu force dang khalom na lai chola na, T2 sin 30 to 1 by 2, so T2 by 2. Okay, so now the whole system is at rest. Okay, all system is at rest, so net force everywhere is 0. Masapenan chu along the so let's say along the x-axis fx equals to 0, na ax 0 has so I have root 3 into T2 by 2 plus minus T1 by 2, so this is equals to 0. Hotele being put answer here. Root 3 T2 should be equals to T1. Na anu ya 2 to 2 cancelling. Okay, you have one relation here. Okay, let's say this is equation 1. 2 in along the y-axis. Along y-axis ham. So Fy equals to 0. Na whole system rests there. So here what do you have? So root 3 into T1 by 2 plus T2 by 2 plus minus 10 equals to 0. LCM na lesson piha. So root 3 into T1 plus T2 minus 20 equals to 0. Okay, so multiply everything by 2, you'll have this. Upon let's say I have it. Equation number 1 ahi T1 so piha root 3 times of T2 so na. So here in place of T1 you put this value root 3 times of T2. Okay, I'll solve here. So root 3 into t1 here to root 3 times of t2 plus t2 should be equals to 20. So root 3 into root 3 is 3. Okay, 3t2 plus t2 equals to 20, right? So you have 4t2 equals to 20. So therefore, what is t2? t2 is 5 Newton. t2 is 5 Newton. So finally, you put this t2 here. Okay. T1 is per time. So t1 equals to, so root 3, so 5 root 3. Okay, so that is t1. Answer to piham. Answer to 5 Newton. T1 is 5 root 3 and t2 is 5. So 5 root 3 and 5. Okay, so here this is 5 root 3. Correction. Okay, so now let's use that Lami's theorem here. Lami's theorem so piham chilai block ite am na chi chilanga hi izata. So this is t2 I think. Okay, t2 abana chu chilanga hi t1 oma anui langa hi 10 Newton cha chila hi. Kutele angle ke pi ho chu vele chun. So here you're given that this is 30. Okay, so this is 60, right? 60 30. Okay, see, I have, okay, so I have t2 along this side, I have t1 along this side, I have 10 Newton along this side. So see, t1 to 10 ki ka I value chun chi 90 na chi 60. So total is 90 plus 60. 90 plus 60 choose ha. So I have 150. Okay. Abanle zilang ko value chun t2 to 10 ki ka ako. So this is 30. So this is 90. So 30 plus 90 is 120. Okay, so this is 120. Kutile so what would be the remaining? Out of 360, you subtract 150 plus 120, that is 270. Out of 360, 270 means 90. Okay, so this is 90. Kutila chun chilahin velation t1, t2, 10, 3 forces, and we know the angle between them, right? So now you can apply Lami's theorem. So what will you have? So t1 by sine 120 equals to t2 by sine 150. Okay, so this is equals to 10 by sine 90. Now it's short trick here too. So now if you want to find out t1, you can use these two equations. Okay, right? So t1 by sine 120 to be 90 plus 30. So this should be equals to 10 divided by sine 90. Chiteni bo se kamana jong ka solve thei cho jela hi khutila chi solve thei jong ha. So sin t1 by sine 90 plus to cos ta cho pen cho. So cos 30. So this is equals to 10 sine 90 to 1 na. So therefore what is t1? t1 is 10 cos 30. Cos 30 to root 3 by 2. So that means 5 root 3. Okay, we got the answer directly. Khutila t2 holding as a pin bolngai ham. So you have to equate these two, right? So t2 by sine 150 to be 90 plus 60. So this is 10 divided by 1. Okay, 10 divided by sine 90. So t2 divided by cos 60. Okay, so sine 90 plus to cos na. The big angle solve down basic maths lecture so just go back and see from there. So these things you have to know. Sine 120, sine 150, sine 270 the hovel hai. So sometimes we use it. Okay, you have to know how to solve this. Kutila chilai 10 na. Chilai ko na so t2 chizat hamponam. So 10 into cos 60 to 1 by 2. So this is 5 Newton. Okay, so now you can see that t1 is how much? 5 root 3. t2 is 5 Newton. Okay, so that is your answer. Lami's theorem here. So if you know how to apply these things, so it gives you a very short answer na. Chilai to compare lesson, so it is much more simpler. Okay. Okay, next question. Another JE question na. Mass to 1 kg ke painting. So it is suspended from a ceiling of a length of 4. Okay. I think this is from NCRT. Okay, I think there is one similar question in NCRT textbook. So a horizontal force of F is applied at the midpoint of the rope so that the rope makes an angle of 45 with respect to the vertical axis. So the magnitude of F is Hotele tang free body diagram ka ji pe. So first let's use the normal method na. Hotele chelanga hi T1 uma hilanga hi force F uma anu hilanga hi biha weight to 1 kg weight to 10 newton na. Gatang T2 pa hi 10 dasme. So I have 1 kg like this. Okay. So here I have T2. So downside I have 10 newton. Hotele chun everything is at rest. Hotele T2 so biha T2 will be 10 newton, right? Okay. Hotija jo chala direct at 10 newton ka ji ta cha jara T2 hela chun. So here they ask you the force. D1 pahi, it is neither along x nor y. T1 pahi at some angle arm chalana. So you take the component of T1 angle to 45. Okay. So that means you have T1 sine 45 and T1 cos 45. Right? So here first along x-axis is a T1 sine 45 to 1 by root 2 na. So T1 by root 2 plus minus F equals to 0. Okay, everything is at rest. Hotele force to yung po ng force to T1 by root 2. T1 to ki hello chala na. Okay, so next along the y-axis. Y-axis lang aso piha. So T1 cos 45 to by root 2. So T1 by root 2. So plus minus 10 equals to 0. Okay. Kutila chalai ko na hi T1 by root 2 chuzat hang ponam 10 chukulangan sila 10, right? So what is T1? T1 is 10 root 2. Okay, now we have found T1. Question chun pido ham force ado chulan na. So now you put this T1 value here. So how much will you have? So 10 root 2 divided by root 2. So which is 10 Newton. Okay, so answer is 10 Newton. Chalai option haokipiit hila. So these are option for the previous question. So answer should be 10 Newton. Okay, now let's use that Lami's theorem. Kutile ipita T1 so chilanga ma. So this is T1. So this is force F, and downwards I have how much? 10 Newton. Must have an angle to with 45 11 90 na. So that means this is how much? 90 plus 45. Okay. So if this is 45, then this is also 45. So this side also 90 plus 45. Okay. And this side I have 90. 90 plus 45. Okay, so how much is this? 90 plus 45. So how much is this? 90. Right? So use that equation. So force divided by sine 90 plus 45. So this is equals to T1 divided by sine 90. So this is equals to 10 divided by sine 90 plus 45. Kutile force ka loading ala chun he chipa to hin chipa ka equate ngai chula na 10 here. So you equate them. So if I equate them, I have 4 F by sine 90 plus 45. So this is equals to 10 divided by sine 90 plus 45. Nu ya teni ki cancellation force is aram ponam. Force is 10 Newton. Okay, direct answer. Right? Okay, let's move on. So the last topic, pulley problems. Pulley ke ti hin chula na well na naiwa la chun well tui khaina ake paiji pa khona. So that is an example of a pulley. Okay. For example, see, suppose I have pulleys like this. Hita ke jiji bet say pulley. Here around the pulley you will have a rope, right? So like this. Okay, hang pia question ki you will have something like this. So one mass is here, M1. Another mass is here, let's say M2. Suppose here I say M2 is greater than M1. Nah, and the system is released. Okay, if I release the system, a motion to itabang hidem. M2 linzo so na M2 gizo aiziachu. So the whole thing will go like this. M2 will go down and M1 will go up. Direction of acceleration too. So acceleration will be like this. Okay, M2 will go down and M1 will go up. Question at M1, M2 hong kipiting itin direct na. What is the acceleration? Okay, they will ask you directly. So let's try to derive something here. first you draw the free body diagram. Okay, so on M1, but the important thing here is, you see, we are using the same string here. Okay, the same string is passing through here, both it is joining both the masses M1 to M2. He string ki bangin na, same string in a join, so therefore you will have the same tension. So what do I mean by that? I will have here T, so here also I will have here T. Okay, so you draw M1 M1 diagram. So chala T kanading, so downward I have M1 into Z, weight chala na abana M1 here chung langa acceleration a chi tau. So next I have M2 so this is M1, next I have M2, so downwards I have M2 into Z, the weight, upwards I have tension T, and the acceleration is downwards. Okay, so every force is along the vertical. Okay, kutile vertical force parts among leo chunjat ha. So in M1 mass, so T plus minus M1 into Z, so this is equals to M1 into A. Acceleration pa chung nga chi tau chala na, so acceleration is positive. So here I have T minus M1 into Z, so this is equals to M1 into A. Let's say this is equation 1. Okay, abale in M2 mass, so there I have T plus minus M2Z, so this is equals to M2 into, so now I will have here minus A, as is acceleration to downward tacho. Now, so here what do you have? So T minus M2Z, so this is equals to minus M2 into A. Kutile equation number 1 to 2 he minus bowling na. T cancel it also. Okay, do equation number 1 minus 2. Okay, 2 minus 1 the ball hollow. But I want a better answer na. So T minus M1Z, so this is 1 minus, so T minus M2Z, so this is equals to M1A minus of minus M2A. So from here see, T gets cancelled out. Okay, T minus T gets cancelled out, remaining to minus minus plus na, so minus M1Z minus minus plus M2Z, so this is equals to M1A plus M2A. Right, from here what do you have? So M2 minus M1 into Z common akala, so this is equals to what? M1 plus M2 into A. So finally what do you have? Acceleration is equals to M2 minus M1 divided by M1 plus M2 whole Z. Okay, direct formula for acceleration. Acceleration do wala chunna chipeni dan chila he pi zoom va M2 he greater e zoom chula na, so M2 is greater, so the greater mass minus the smaller mass, that means the difference in their masses divided by the sum of their masses into Z, so that will give you the acceleration. Okay, so once you find out the acceleration, if they ask you tension, whatever acceleration you got, you just put it here. Okay, and then solve for T. Right, you can also find a formula for T. Okay, but so what in order to find T, what do? You have to put this value here and then transfer this here. You'll just find for T. Okay, let's solve here. How many questions we have? We have 2 questions more. Okay, let's just solve this one quickly. It's a neat question. You're given 4 kg and 6 kg. Kutile chi M2 pen hi M1 na so M2 is greater than M1. The string passes over the frictionless pulley. Acceleration direct ado so kutile acceleration so the difference in their masses divided by the sum of their masses into Z. So 6 minus 4 divided by 6 plus 4 times Z. So this is your answer. How much is this? 6 minus 4 is 2, 6 plus 4 is 10 times Z. So this is Z by 5. Okay, so that is your answer. Next to PM, see, normal method is on the solve it. So you can solve this using normal method. You draw the free body diagram. So 4 kg, you have 40 Newton. Okay, so along this you have T, right? And then you have 6 kg. So 6 kg is 60 Newton. Along this you have T, so this goes down with acceleration A, and this goes down up with acceleration A. So the force equation is so exactly like this. Okay, so whatever we have drawn written here, so the normal method will be like this. Okay, equation subtract the equation 10, so you have to subtract them again, and then you'll find the same thing again. Okay, so better remember the formula, otherwise you can also do the normal method. Okay, so up to you. Okay, so finally, last question. A light string passes over a smooth blah 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 m1 m2 if the acceleration, okay, A is given. Question ratio of mass at the A formula A formula to difference in their masses divided by sum of their masses into z. So difference m1 m2, let's say here m1 m2 is greater. Okay, question also be given so m2 is greater than m1, let's say. So that means you'll have m2 minus m1 divided by m1 plus m2 into z. Abana acceleration z by 8 kp. So this is given as z by 8. So these two gets cancelled out. So what is the remaining? So cross multiply volume m1 plus m2. So this is equals to 8 m2 minus 8 m1. So transfer m1 on the left side, m1 plus 8 m1. Transfer m2 on the right side, m2 minus m2. So from here I have 9 into m1, so this is equals to 7 into m2. So what is the ratio of m1 by m2? So you'll have 7 divided by 9. Okay, or m2 by m1 so is 9 divided by 7. Question of value 9 by 7 so that is your answer. Okay. So the lecture here normal force to tension force bolo here na. So I think I've covered all the basic things, and we have solved some questions regarding that. Regarding normal friction will palo tension jong normal jong avela question zoom in solve kidiu na. So when all of them are combined, we're going to solve those questions. See video bol ho hi lesson basic clear na dinga so na tension force ding dan force equation apply ding dan it's also hin about a normal azong hin. So basic normal things we have learned. Okay, so we'll stop the video here. I hope you understand. Next video pala friction involved. Okay, so that much. So thank you for watching. I hope you understand.